The James Webb Space Telescope JWST is acknowledged as the leading global space exploration instrument and astronomical observation tool. Its principal aim is to examine the mysteries associated with planets in our solar neighborhood, circling distant suns, and the complex structures that compose the universe, along with our place within it, in a groundbreaking effort. Scientists recently directed the JWST toward a star located 120 light-years away from us. By doing this, the initiative and advanced technology of the telescope uncovered compelling evidence, implying that there are carbon-based substances within the atmosphere of a conceivably submerged planet far away beyond Earth, leaving researchers across the globe amazed. But how was such a spectacular discovery made? This revelation offers a mesmerizing perspective on a world drastically different from those in our solar system, while also raising profound questions about the possibility of life sustaining planets throughout the cosmos. Join us as we delve into this exoplanet breakthrough and reveal the fascinating details it provides. If you're keen on staying current with the latest developments in astronomy and beyond, make sure to sign up for our channel. Give this video a like, share it, and enable notifications for future updates. NASA's James Webb Space Telescope has accomplished a significant advancement in studying the exoplanet K218b, a celestial body with a mass approximately 8.6 times greater than Earth. What makes this observation particularly exciting is the detection of gases that carry carbon, like methane and the carbon dioxide it contains in its atmosphere. This backs up earlier research suggesting that K218b could offer conditions favorable to life. The world appears to be enclosed in an atmosphere dominated by hydrogen and possibly harbors a liquid ocean on its surface. The initial analysis of this atmosphere conducted by NASA's Hubble Space Telescope significantly improved our understanding of this far-off system. It's noteworthy that K218b is situated about 120 light-years from Earth in the Leo constellation and revolves around the cool dwarf star K2218, residing in the habitable zone of the star. Planets such as K218b, which fall between Earth and Neptune in scale, are rare in our solar system due to the absence of planets in this specific dimension here. The hypothesis that K218b contains significant carbon compounds and an atmosphere high in hydrogen has fascinated space scientists. Many speculate that such worlds may provide the most likely locations for locating possible indices of life. The identification of methane and carbon dioxide without any ammonia present lends further weight to the idea that this exoplanet may feature an ocean beneath its hydrogen-laden skies. Early analyses have also hinted at a possible detection of dimethyl sulfide, a chemical associated with biological activity on Earth. The molecule here is mostly produced by oceanic plankton on our planet. Nevertheless, its existence on K218b remains uncertain and requires more evidence for confirmation. Upcoming observations using JWST's scientific instruments are expected to determine whether or not there is dimethyl sulfide in notable amounts in the planet's atmosphere. A researcher from the University of Cambridge stated that although K218b lies within a zone where liquid water might persist and contains carbon compounds, this is not conclusive evidence that life exists on the planet. The planet's diameter is roughly 2.6 times larger than Earth's. It is probably surrounded by a thick, high-pressure, icy mantle similar to Neptune, with a hydrogen-based thinner atmosphere and a surface that may encompass vast oceans. Even if these oceans do contain liquid water, they could be excessively extreme, or the pressure or chemical composition could be unstable for life to flourish as we know it. However, scientists have now achieved the most accurate atmospheric profile yet of any habitable zone sub-Neptune exoplanet, enabling them to determine the presence of specific elements in its gaseous layers. One team member from Cardiff University gave an account of how they overcame observation difficulties by studying the passage of light from the stars through the exoplanet's atmosphere. K218b is a transiting planet, which means that when it moves in front of its star, it partially blocks its light. That's how NASA's K2 mission first discovered it. During these transits, some of the starlight filters through the planet's atmosphere before reaching our instruments. Telescopes, like JWST, can read the chemical signatures carried by this light, which aids in the identification of the gases present. The researchers hope to continue their investigations using JWST's mid-infrared capabilities to verify the composition of the planet's atmosphere and gain deeper insight into K218b's climate and surrounding conditions. Their ultimate objective is to look for biological traces on potential life-sustaining planets, a project that could completely alter our grasp of the universe. Beyond this, JWST has uncovered additional remarkable insights. Scientists utilizing the telescope have identified complex organic molecules comparable to smoke or atmospheric haze in a far-off galaxy. This signifies the earliest known detection of such materials in the universe. Personally, I find this both awe-inspiring and unsettling, as these findings from the distant cosmos challenge fundamental assumptions. What's especially significant is that these molecules, known as aromatic hydrocarbons, were found in a galaxy that formed when the universe was merely 10% of its present age. These carbon-heavy molecules, frequently found in oil, coal, and even urban smog, are large and intricately built, made up of dozens or even hundreds of atoms. What's especially shocking is how such elaborate structures came into existence so soon after the Big Bang. Bang! Defying older models of cosmic development. To put this into context, the light we now perceive from this ancient galaxy began traveling only 1.5 billion years after the universe began. Because the universe is approximately 13.8 billion years old, we're essentially observing its initial phase. What's even more astounding is that this finding was made possible by the Webb telescope, and it will continue enabling such discoveries for almost another billion years of observable cosmic history. If we could peer even further back in time, might we find even earlier traces of these intricate compounds, getting closer to the universe's origin? This raises profound concerns regarding our understanding of the cosmos. Previously, astronomers could only speculate about the existence of such organic matter in the early universe. But with JWST's superior resolution, we can now pinpoint exactly where these compounds reside. Additionally, the uneven distribution of these atoms in the nascent galaxy SP41847 remains a mystery. Remarkably, this galaxy already had enough mass similar to the Milky Way and generated equivalent amounts of carbon and oxygen. Despite being only a fraction as old as humanity pushes deeper into the cosmos, ruled by reason and scientific advancement, we are frequently amazed by the immensity and intricacy of the universe. Each breakthrough nudges us closer to deciphering the scattered secrets across the stars. Due to the ongoing progress in international space research, there will undoubtedly be more discoveries in the future. The secrets of the universe are being revealed, helping illuminate our role in the grand design. Let us know your thoughts in the comments. If you enjoyed this video, make sure you subscribe and tap the bell for notifications. As our universe's James Webb Space Telescope gains popularity, it continues delivering groundbreaking revelations. Its observations are reshaping our perceptions of remote planets and stellar structures, pushing the boundaries of what we understand about the cosmos. This amazing telescope lets us peer deeper into space than ever before, revealing questions that previously evaded scientific examination. The identification of complex organic substances in primordial galaxies is just one illustration of JWST's impact based on what we know about the early universe and its evolution. Perhaps the most riveting aspect of these findings is the idea that life, or at least its foundational components, might exist in areas that were once thought to be inhospitable. The discovery of carbon-centric chemicals in the atmospheres of planets like K218b paves new avenues for investigating possible biosignatures on planets that may mirror Earth in some respects. These substances, including methane and carbon dioxide, are closely associated with biological activity on Earth. Nonetheless, their presence on faraway planets does not prove life. It simply encourages additional investigation into whether such environments could sustain living organisms. Future missions by NASA will intensify their focus on this extraordinary potential. JWST's capability to meticulously analyze exoplanetary atmospheres represents a major stride forward. It empowers scientists to detect not only basic elements, but also cutting-edge chemical patterns that might suggest biological processes. This level of specificity is crucial in determining whether distant planets can be inhabited. As our understanding deepens, so too does our ability to identify subtle indicators of life, whether through gases in the air, organic residues, or other signs of biological activity. Beyond exoplanet exploration, JWST is producing important insights into galactic evolution. By looking at ancient stars, astronomers can show how galaxies are born, how materials are dispersed, and what mechanisms shape galaxies over billions of years. This is vital to uncovering the origins of the Milky Way, our very own galaxy. The detection of aromatic hydrocarbons in a galaxy that existed before our own highlights just how much we are learning about the early universe as we continue our journey through space. Each discovery brings us closer to answering some of the most profound questions humans have ever posed. Are we alone in the universe? What gave rise to life? What is the ultimate fate of the cosmos? These questions have captivated scientists, thinkers, and dreamers for generations. Now, with pioneering devices such as the James Webb Space Telescope, we are better prepared than ever to look for those answers. Each new revelation broadens our perspectives and moves us closer to uncovering the truths that lie beyond the stars.